So let's take a look at the logarithmic function. To start, let's graph y equals 2 to the exponent of x and its inverse. So let's start with x values from -3 to +3. For y equals 2 to the exponent x, 2 to the exponent of -3 is equal to 1/8. Then we get 1/4 and try to determine the remaining y values. We also want to graph the inverse, so what we're going to do is we're going to switch x and y. Now let's graph the exponential function and its inverse. We can see that the inverse of an exponential function is also a function. For every x value in the domain, there's only one y value or one output. Take a moment now and complete the following table, and then check your work. We notice for an exponential function that the domain is x is any real number, and the range is y is any real number, but y is greater than 0. And we can see that is switched for the inverse. Recall that an exponential function has a horizontal asymptote, which we can see right here. And for this example, it's at y equals 0. And for the inverse of the exponential, we see it has a vertical asymptote at x equals 0. We notice we only have intervals of increase for both the exponential and for its inverse. And there are no intervals of decrease. The inverse of an exponential function is what we call a logarithmic function. So normally when we look for the equation of an inverse, so for our example here, we had y equals 2 to the exponent x. If we want to graph f inverse, we switch the x and the y. To isolate y for the expression x equals 2 to the exponent y, we write it as a logarithm. So y equals log base 2 of x, where this is the base of the exponent. This is the value of the power, and the y is our exponent. And we've talked about inverses before. You see them all the time. If you had x squared, we know that its inverse is the square root of x. If you have cosine of theta, we know its inverse is cos minus 1 of theta. So for exponents, their inverse is called a logarithm. Let's examine one more exponential equation and its inverse. So again, try to complete the table values yourself and then check your work. This time we took an exponent that has a base value between 0 and 1, and notice we have a decreasing exponential function, which this time gives us a decreasing logarithmic function. We still have a horizontal asymptote at y equals 0 for our exponential, and again we have a vertical asymptote at x equals 0 for our logarithmic function. Clearly the inverse is a function. For every x value in its domain, there is one possible y value. So next, try to complete the chart yourself again, and then check your work. So notice for this table, all the parameters are still the same, except for our intervals of increase and decrease. Since we had a value between 0 and 1 for our base, we end up with a function that decreases for all x in the domain. Again, if we want to state the inverse for an exponential function, so recall for this example, we have y equals 1/2 x. If we switch the x and the y, we get x equals 1/2 to the exponent of y. If we want to isolate for y, we rewrite it as a logarithmic function. Again, where the 1/2 is the base, the x is the value of the power, and y is the exponent. So let's quickly summarize what we've just seen. So if you have a function y equals a to the exponent of x, then the inverse function is y equals log to the base of a of x. When the a value is greater than 1, then the exponential function is increasing and the logarithmic function is increasing. And when it's between 0 and 1, the exponential function is decreasing as well as the logarithmic function. With exponential and logarithmic functions of the following form, we know we have a horizontal asymptote at y equals 0 for the exponential and a vertical asymptote at x equals 0 for the logarithmic. If you look at the graphs, we see that there is always a y-intercept of 0 and 1 for functions of this form. And since the logarithm is the inverse, then we have an x-intercept at 1 and 0. Domain for an exponential is x is any real number, and for logarithmic is x is any real number, where x must be greater than 0, which matches the range of the exponential. Y is any real number, where y is greater than 0, and then for the logarithm, y can be any real number. Let's talk a little bit more about logarithms. If we want to determine f inverse of x for the function 7 to the exponent x, let's go through our steps. We have y equals 7 to the exponent x. We switch x and y if we want to graph them on the same grid. We rewrite as a logarithmic function. So y equals log base 7 of x. And then we use our function notation. So f inverse is log base 7 of x. So to go from here to here, we use logarithms. And we should be able to go the other way. What if I want the f inverse of the function log base 4 of x? So we have y equals log base 4 of x. We switch the x and the y. To isolate for y, we rewrite this as an exponential. So that's y equals, the base is 4, and then there's our exponent x, which means that f inverse is equal to 4 to the exponent of x. So from here to here, to isolate for y, we rewrite as an exponential. So let's talk a little bit more about logarithms. So let's evaluate each of the following logarithms without a calculator. All you need to remember is that this number here is our base, and that this number here is the value of our power. So if I let this equal x, I can rewrite this expression. So I get 7 to the exponent of x is equal to 49. So what exponent on 7 will give me 49? Well, that would be x is equal to 2. So this means that the log of base 7 to the 49 is equal to 2. The answer to a logarithm is the exponent for the given base. So let's do the same thing with the next one. If I let this equal x, I get that 2 to the exponent x is equal to 1/4. Remember that 1/4 is the same thing as 4 to the exponent of -1. And we know that 2 squared is equal to 4. And using some of our exponent rules, we see that we get 2 to the exponent of x is equal to 2 to the -2. So if you can go from here to here, that's great. So 1/4 is equivalent to 2 to the -2, so that means in this example x must be equal to -2. And if we used our calculators, we would see that the logarithm of base 2 of 1/4 is equal to -2. And for our last one, notice I don't see a base here. If you don't see a base, then it's base 10. So this would be the same as log of base 10 of 1000. Which if I let that equal x, I'm looking for whatever exponent on 10 will give me 1000. And you can go right to the answer, or if you like to simplify first, I know that's 10 to the exponent of x, and on the right side we get 10 to the exponent of 3, so therefore x is equal to 3, which tells me that the log of 1000 is equal to 3. And this one you can try on your calculator because you have a base 10 log button. And if you type in log 1000, you should get the answer of 3. So try the following questions. And if you have any questions, please let me know.